Welcome to The Explainer. Today, we're diving deep inside the skull to talk about a really serious medical condition called intracranial hypertension. You can think of it like a pressure cooker inside your head, and we're going to break down exactly what happens when that pressure gets dangerously high.
So let's just start with this one. Simple question, because the answer to this really sets the stage for everything else. It reveals just how incredibly fragile our most vital organ truly is.
You know, before we can really understand what goes wrong, we first have to appreciate what normal looks like. And the environment inside our skull, well, it maintains this incredibly delicate equilibrium. It's a true masterpiece of biological engineering.
At the very heart of this whole balance is something called intracranial pressure, or ICP for short. And really, all that means is the total pressure from everything that's packed inside our skull. You've got the brain tissue itself, all the blood, and this special fluid that acts like a cushion.
And here's the wild part. In a healthy adult, that pressure needs to stay in a super narrow range. We're talking just 5 to 15 millimeters of mercury. There is almost no room for error.
So why is it so strict? Well, it all comes down to basic anatomy. Your skull is a hard, bony vault. It can't stretch or expand. This basically creates a zero-sum game inside, which is governed by a rule known as the Monroe-Kelly doctrine.
And this chart here breaks it down perfectly. About 80% of the space is taken up by your brain. The other 20% is split pretty evenly between blood and that cerebral spinal fluid, or CSF. Now, because the box is sealed, if any one of these things increases, something else has to decrease to keep the pressure stable.
Okay, so that leads us to the big question. What happens when something new, like an uninvited guest, tries to squeeze into this already packed space? Well, that's when the trouble really starts.
And this intruder can be a lot of different things, right? It could be swelling from a bad head injury, bleeding from a ruptured blood vessel, a growing tumor, or even just a backup of that cerebrospinal fluid. Anything at all that adds volume inside this closed box kicks off a really dangerous chain of events.
Now, this is absolutely crucial. As the pressure inside the skull, the ICP, starts to climb, it basically acts like a clamp. It makes it harder and harder for fresh, oxygenated blood to get pushed into the brain. The pressure that drives that blood flow is called cerebral perfusion pressure, and if the ICP gets too high, that perfusion pressure drops, and the brain literally starts to starve.
But before things get totally out of hand, our body is pretty smart. It has a couple of temporary tricks up its sleeve to try and buy some time, to make a little extra room.
So what's its game plan? Well, first, it tries to get rid of some of that CSF by shunting it out of the head and down the spine. If that doesn't do the trick, it then starts compressing the veins to literally squeeze blood out of the skull. But these are only short-term fixes. And that's the problem. These tricks can only work for so long. Once you've pushed out all the extra fluid and blood that you can, you've got nowhere else to go. The body is out of options. And that pressure curve starts to shoot straight up. We're getting dangerously close to a catastrophic tipping point.
And this is where we hit the climax of the crisis. The body's defenses are just completely overwhelmed. With nowhere for that pressure to escape, it starts to crush the one thing it's supposed to be protecting, the brain itself.
The official red line is 20 millimeters of mercury. Once that pressure stays above this level, it's officially defined as intracranial hypertension. The brain is now being actively damaged by the force that's building up all around it.
At this late stage, the body sends out this bizarre last-ditch alarm signal called Cushing's triad. And check this out. Your blood pressure goes through the roof as your body desperately tries to force blood into the brain. But this causes your heart rate to plummet, and your breathing gets all irregular. It's a total paradox. And it is a massive red flag that the brainstem is in deep trouble.
And this is what everything has been leading to. The absolute worst-case scenario. Brain herniation. It's as bad as it sounds. The brain is literally being squeezed so hard that parts of it are forced out of their normal spot and into other areas, causing severe, often irreversible damage, and it can lead to death.
So, when a patient gets to this state, you can imagine it is an all-hands-on-deck emergency. It is an absolute race against the clock. And medical teams have a very clear, systematic way of trying to get that deadly pressure back down.
And they have a playbook for this. It starts with the fundamentals, like simply elevating the patient's head. If that doesn't work, they move on to powerful osmotic drugs that literally pull water out of the swollen brain. As a temporary fix, they might hyperventilate the patient to shrink the blood vessels. And if all else fails, the final steps are invasive. draining fluid directly out of the brain, or even surgically removing a piece of the skull just to give the brain room to swell.
So when you step back and look at the whole picture, this entire crisis is just a stark reminder of the brain's incredible vulnerability. It's all about this constant, hidden battle that's fought inside the rigid confines of our skull, a battle to maintain a fragile balance where just a few millimeters of mercury can truly be the difference between life and death.